Okay, guys, I need you guys. Please don't make me break up the tables. I will break them up if I have to keep interrupting you. So thank you. Let's be respectful. I appreciate that. We're here to focus and learn. Thank you. All right. So domain and range. Um, so as I talked about before, you may want to use a calculator to see how these look. So let's go to Desmos really fast. Desmos. And let's do y equals square root x. Remember, square root, you can type SQRT into Desmos. So if we think about it, you can't square root negative numbers. That's just weird. So, and I look at the graph itself. The graph clearly starts at x equals 0 and goes forever to the right. So what would I say would be the domain for root x? Remember, domain's x. So what are the allowed x values for that? Go to Alexander. Perfect. Excellent. That's how you want to write it. Now, if you actually write it in words, you could also say this. All real numbers. If you're a verbose person, you like to be wordy. You could do that. Personally, I like this better. Easier on the eyes. Be easier for you guys to write. But if you want to be explicit and say, hey, all real numbers greater than or equal to 0, that's cool too. That works. There's also another way you could write it as well. And actually, I'm really going to actually emphasize this a lot this year because apparently this is the expectation for the pre-calculus students, and some pre-calculus students are kind of struggling because we didn't emphasize this enough in this class. This is called interval notation. It's probably the first time you guys are seeing this. I'm not sure if anyone's seen this before. Has anyone ever seen interval notation? Okay. Yeah. You know what this? Can you tell us what the bracket means? Right, but there's two ways you could write it. I could write like this, or write the bracket. Do you know the difference between the parentheses and the bracket? Okay, that's fine. No worries. I was just curious if you knew. The bracket means included. So the way this works is that you start at 0 and you go towards infinity. Because if you think about it, where does the graph start for x? At 0, right? And what does it go towards? Infinity. So that's called interval notation. The way interval notation works is the bracket is included. The parenthesis is not included. Infinity means you go to the right. Negative infinity means you go to the left. Clearly, we're going to the right. And of course, it starts at 0. So that's how you'd write. I'm going to do this a little bit more just so you kind of get the hang of it. If you want to write an inequality, that's fine too. But ultimately, as we get later in the semester, I'm going to force you guys to use interval notation because that is a standard for all your math classes moving forward. And so
Can you put other numbers in there instead of the infinity?
No, we have to do infinity because you have to show it's going forever. There's no stopping it. It's going forever to the right. Let me actually give you guys some other example. What if I had this, just so you guys get the hang of what's happening here? What if I had what if I did that? Okay. So in this case, it ends at 0, right? And it's coming from the left side. So you write like this. You can say x is less than or equal to 0. But it's going from negative infinity to 0, stopping at 0. So you always go from left to right. There is no left bound, but it stops all the way at 0. Let me kind of just throw some other ones that are kind of random. What if I did this here? Okay. So I did x plus 1. Where is it starting, guys? And it's going forever to the right. So I'm going to write like this. Bracket negative 1 infinity. Okay. As you start seeing this more and more, you start embracing this a little bit better. Or say x is greater than or equal to negative 1. So, okay, let's keep going, guys. So this one here, again, x is greater than or equal to 0. Or you could write like this. That's my domain. Now my range, let's go back to the graph again. Okay, the range, that's X. There we go. All right, range. Range is Y. The range is the Y coordinates. So domain's X, left, right. Range is up, down, right? What's the lowest Y value here?
Zero.
And is the graph rising or falling?
Rising.
So you're gonna say Y is greater than or equal to 0. Or you could write like this. So now the infinity refers to up, and then negative infinity refers to down. Okay. That's happening with that one. Let's do a few more here. So domain range is a big deal. We're going to do a lot of domain range in this class. Let me make some partitions here. Okay. Now, let's do this without a graph. Let's put our thinking caps on. G of x, negative parentheses x minus 2 squared. I don't see a square root, so I don't have to square root negative numbers. I don't see a fraction, so I don't have to divide by 0. Are there any restrictions for g of x, or can I do whatever I want for g of x? I think my facial expression made it away. Can I do whatever I want for x, or is there a restriction? What are the restrictions for g of x for us? Yeah. Or can I put whatever I want? Whatever.
Well, I mean, technically you could, but.
Yeah, I could.
But like,
I can put whatever I want for x. The range is restricted. We'll talk about that in a moment. But for x, I can do whatever I want. It's gonna be all real numbers. Or we write like this. If you look at the graph itself, negative x. And perhaps you guys might be confusing this with range because the range will be limited. Let me clear this for a moment. But take a look at the graph. I can do whatever I want for x. Can I plug in negative 1,000? Sure, why not? Can I do negative 4.875? Sure. Can I plug in like 1,000,000? Sure. I can do whatever I want for x. There's no restriction for x. So x, so the domain's all real numbers. Because it's going forever, both left and right. Because it's going forever, both left and right, that's why I could also write like this. From negative infinity to infinity. Now, I told you the bracket means included. So if the number's included, so I can square root 0, that's fine. But how come I don't do brackets for infinity? Do we know what infinity is? Do we know what the biggest, largest number possible ever is? We don't. It's this abstract idea that keeps getting bigger and bigger and bigger, right? We don't know. So we put parentheses for that. But the range is limited. The range is y. Now, there's definitely not a restriction so much because it's a dependent variable, but there is a limit. How high does y go here? What's the highest y value on this graph?
0.
0, good. And it goes down forever, right? Because of the negative in front. So that's going to be going back to my table here. That's going to be y is less than or equal to 0. Sorry, there's supposed to be a parentheses there. Negative infinity, 0. So remember, parabolas have high points and low points. So those ranges will be limited. The domains won't be. Okay, this is kind of a weird one. We haven't talked about this yet. 2 to the x minus 7. It's an exponent, right? Let's look at the graph first. Yeah, totally. 2 to the x minus 7. So let's do that. 2 to the x. Can we clear the screen for a moment? Okay, look at this graph. Looks like it's going forever to the left. It's going forever to the right. Now, of course, it goes up like crazy because it's exponential. It's an exponent. Is there any reason why I can't plug in a certain number for x? Or can I do whatever I want for x? For exponential functions, think about it. Do we have a fraction with x in the bottom? No. Do I have a square root? No. Those have restrictions, right? Because you can't divide by 0. You can't square root negative numbers. But if you're just putting an exponent, like who cares if I put 2 to a negative number? Do you guys remember what that is from last year? Or actually, no, sorry, you guys didn't do this last year. Does anyone know what this is, by the way? At least good. Yeah, exactly. Have you guys seen that? Yes, no, maybe, I don't know. Maybe algebra 1. But the bottom line is you can do negative exponents or fraction exponents. That's totally fine. So yeah, it's all real numbers again. We'll explore exponential functions in the spring, I think. But yeah, still all real numbers. Or you could write like this, negative infinity to infinity. However, that's not true for y. And this you guys haven't understood yet. But I'm going to help you understand just a little bit. Let's take a look at the graph again. Y shoots up forever, right? There's no ceiling. Sky's the limit. It goes up forever. But as we go down, it's tapering off or leveling off. Where do you think it's leveling off at? For what? For Y?
-6.
Yeah, it's like -6.9999. It's getting really close to -7, right? So see, this is the beauty about Desmos. You can investigate this really nicely. Like, okay, it does say -7, which is actually that's false. That's not really true. It's just rounding. But see, that's getting really close to -7. But it's not going to touch it exactly. Yeah, it's getting really, really close, right? It's getting awfully close. So in this case, you're going to say your range is just y is greater than -7. And you don't include -7 at all. How come we don't include it? Let's think about it.
It doesn't touch -7.
Well, yes and no. But no, you're right. You're right. That's not what I'm looking for. But you are. Think about what this is, 2 to the x. Yes, think about that. Actually, I'm glad we're having this discussion. This is a really good discussion about it. Really good discussion about it. Okay. Yeah, do you guys want 2 to 4 powers? I'm sorry, I had a question.
No, I was just gonna see. If that's accurate.
Yeah, go ahead.
Is it because that no exponent is going to be -7, no matter what exponent?
Well, let's talk about 2 to the x. Can 2 to the x ever equal 0? Can you raise 2 to some
Yeah.
power? Right, and that's the reason why. And we're gonna see that in just a moment. But that's the reason why. What's 2 to 4 power? What does that mean? That was good. Close. One more.
Oh, it's right.
16, right? What's the next one? That's 8, right? And that's 4. And that's 2. And then what? Does no one know what this one is?
One.
Okay, why is it 1? Does anyone know why?
Anything from 0.
What was that? Sorry. No, it's the same. Yeah, okay, well, all right. Okay, I'll explain. So I have a AP calculus and still sometimes don't know why this is 1. If you think about it, any number is being multiplied by 1, right? You don't see it, you don't write it because it's redundant. But that's true. I mean, is that a true statement? Sure, why not, right? Of course. Like, for example, if I have 4.67, if I multiply by 1, it's still 4.67, right? So there's always a 1 here. You don't see it. There's always 1 here. Now, what does 2 to 4 really mean? 2 times. Yeah, what does this really mean? What does this mean? And then 1, 2, then how many 2's do you have now? Nothing. But what's being multiplied to the left of it? That's why it's 1. Whenever you raise them to the 0 power, that doesn't exist. You don't have any 2's now, right? Because an exponent means, oh, I got to raise this a certain number of times, right? Or power. So that's why it's 1. Now, when you have negative exponents, I know you guys haven't seen this yet. It's kind of weird, but you write like this. Negative exponent just means you flip it. So what if I do something really big like that? How many times am I multiplying 2?
100 times.
Which is a really big number. So it's 1 over a very large number. Well, if you think about it, this fraction here is going to be super small, right? You're doing 1 over a very large number. But can this fraction ever equal 0?
Yeah.
What has to be true for the fraction to be 0? What has to be true about the top? Can't be 1, has to be 0, right? In order for a fraction to be 0, you need its top to be 0. But you're stuck at 1. This is stuck at 1. So it gets very close to 0, but not exactly. That's what's happening here. 2 to the x minus 7. When I raise 2 to some power, I can't make 2 0. How am I gonna multiply a bunch of 2s? And make it 0? That just can't happen. To have a product be 0, I need one of these to be 0, but I just got a bunch of 2s. Now I could do 1 over a bunch of 2s by doing negative exponent. If I do that, I can have a bunch of 2s in the bottom, but regardless, the top is still 1. So this gets awfully close to 0. Very close to 0. When x goes towards negative infinity, but never 0 exactly. And that's why it gets close to -7, but not -7 exactly. It gets awfully close, like -6.9999, because 2 to the x could be 0.00001, but never close enough. Or sorry, never exactly. Close enough, but never exactly. So that's the reason why. And we'll revisit this whole idea. By the way, what I just kind of explained to you is kind of the beginnings of calculus, believe it or not. So you guys got a little bit of a calculus lesson, but it gets really close, really, really close. All right, last one's pretty simple. It's just a line. I'll just kind of tell you. All real numbers, negative infinity to infinity, all real numbers. That's true for all lines, unless if it's horizontal. It must be the range will be limited. Or if it's vertical, then it's just the x value for the domain. But that's pretty simple. I mean, negative x over 2 minus 1. Right? Not that hard. Okay. I really took a lot of time with that, so I'm gonna move a little faster, guys. But questions? Domain range. Okay, we're cool with it. John, go ahead. Yeah, sure. All right, so now let's move on to the next one. I'm gonna kind of just show you the graph in the interest of time. I'm not gonna put in Desmos. So domain range. Actually, I need more space. I know I don't like it as just copying because I want to explain, but let's copy for a moment, then I'll explain. Okay, let me explain. 1 over x. Can we divide by 0? No, it's impossible, right? You can't divide by 0. Again, how come we can't divide by 0? Because what is division really? The opposite of multiplication, right? Like, I know 10 divided by 5. Why? Because 10 equals 5 times 2. Duh, we know this, right? You guys know this for a long time. What if we do 0 over 2? Of course it's 0. Why? Because 0 equals 0 times 2, right? Duh, totally, we know that, right? But multiply both sides by 2. 2 times 0 equals 0. Right? You know that. However, what about 2 over 0? So what would I multiply to 0 to make it 2? Is there any number I can multiply to 0 to make it 2?
No.
I can't, unfortunately. Can't be done. That's why it says undefined. So that's why 0 is not cool. We can't do 0. Also, the top is stuck at 1. We need the top to be 0 for the whole thing to be 0. So y can't be 0 either. That's why the domain range are both all real numbers except 0. So you have to kind of think numerically what's happening. Now the graph. Why does the graph look like that? There are 2 reasons why. As x gets large towards infinity, y gets closer to 0, but not exactly 0. Okay. Also, as x gets closer to 0 from the right side of the y-axis, y gets really, really big. Think about it. Give me a value of x close to 0. Look at that one.
0.2.
Perfect. Go even smaller.
1.
Go smaller. Oh, 1. Right. Good. Right? Just like a little stutter. 0.001. Right. So if you do like 1 divided by 0.001, or if I just go to Desmos. Okay, let me clear the screen for a moment. Okay, see what happens when I make x smaller? What's happened to y? It just shoots up forever, right? If I do 0.001, I get 1,000. If I do 0.0001, I get 10,000, and so forth. So it just shoots up forever. And the same thing happens on the other side of the y-axis. So you can apply the same principle to the other side. If x is going towards negative infinity, or if x gets closer to 0 from the left side of the y-axis, you get the same thing. So that's what's happening there. These are things we'll explore later on in the year. We'll get really deep with these kind of functions. Now, to do an interval notation, it's kind of weird, but you write like this. Okay. Why am I doing 2 separate things here for the domain? How many branches do I see here? How many like graph, or I'm sorry, graphs, just one graph, but how many different parts of this graph do I see? Two parts. So they both have their own domains. So you gotta write 2 intervals. So for example, this x value gets close to 0, right? So it doesn't hit 0 exactly, so you can't divide by 0, but it's coming from the left side. This doesn't start at 0 exactly, but it's close to 0 and goes forever to the right. And the U, I'm not sure if you guys have seen this before. The U stands for union. Maybe you've seen that. I don't know. In other math class, maybe middle school with set theory. I don't know. But the U stands for union. So you're uniting both sets. Both sets are being united as one group. Does anyone know what this means? Has everyone seen that before? The upside down U? No? That means intersection. All right, don't worry about it. That's fine. Don't have to worry about that. But that's how you have to write it. You have to write as 2 separate intervals, but they're united with the U right there. Likewise for the range, the y values, do the same thing. If you just want to write in words, that's okay for now. But ultimately, we're going to move towards interval notation because that's going to be our standard. Okay, domain. And I got to be watchful of time too. Domain is going to be all valid x values. And range is going to be all allowed y values. Why did I use different words, valid and allowed? Like, oh, actually, good. Yes. Thank you. Yes. Perfect. Yes. What am I allowed to guess? Right. So like, I don't know, trying to think of good example, like my kids depend on me, right? Like my kids don't make money. I make money, I send money to my kids. So what are they allowed to buy? You know, they depend, you know, like they're not like, sure, maybe it's valid for me to buy. It's a terrible analogy. I'm not gonna come with it. Like valid, well, valid could be like, I could choose how much money to spend, but do I have like $1 million? No, I don't, unless I sell my house or my retirement plan. But I mean, I can spend $100 on my kids, I have $100 in my account. So valid means like what you're allowed. Valid means what you could do. I don't know. Maybe I'm just blurring the words. Bottom line is domain's X, range is Y. Let's move on. Okay.
Good.
Yeah, sounds good to me too. All right. Let's look at this really quickly here. Actually, you know what? Let's skip 32 for now. I could do that on Friday with you guys. Did I see you guys Friday? Yeah, Friday morning. Let's skip that for now. 29. Let's do 29 and we'll stop there. Okay. We'll come back to 32 on right. Can you guys stop that, please? Stop your necks. Thanks. Yeah, stop hurting yourselves. Awesome. All right. All right. Here we go. This is a test question. Okay, maybe I got your attention now. This will be a test question in a couple weeks. We are going to ask a question like this. So you're asked to sketch a graph with these parameters. The domains between -3 and 10. The range between -4 and 6. Don't have to make an equation, but you do have to draw a graph. We'll do this together. We won't do it in the teams. So what this means is that you have to start with -3 and end with 10. So 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So let's say I started here. And let's say I ended here. Okay, fair enough. That's fine. No problem, right? Okay. When I do my graph, I'll do my graph something kind of like this here. Okay. -4 is where it's going to be the low point. And that's going to be the high point. Is my highest y value 6? You bet. Is my lowest y value -4? You bet. Fully. So I got a little creative. So I know I have to start -3 and then at 10. I did that. I know the peak is at 6 and the low point's at -4. And there you go. There's my graph. Is my range from -6? Sorry, from -4 to 6. Sorry. Yes, -4 to 6. Yes. Is my domain from -3 to 10? Yes. Could I have done it differently? Sure. Could I have done a graph like this instead? Could I have started at -3, 6? Sure. Could I have ended at 10, -4? Sure. Could I just done a straight line between the two? Sure. That would have been fine too. You could have done it like that. That's another possibility. The bottom line is you have to make sure the domain is from -3 to 10. The range is from -4 to 6. Could I got even more creative? 100%. Could I have done something like this here? Why not? Go for it. Could I just done like something like this here? Sure. That's fine too. So there's no right or wrong answer necessarily, but you have to make sure the range and domain are set correctly. And you'll have some homework problems on that. Don't worry about X for experts. We won't do that. Okay, perfect. This is exactly when I wanted to stop. So we have 15 minutes until class is over. If you want to, if you finish early and you want to get head start on homework, you can. Or if you just need to stare at the ceiling or ceiling fans and you need a break, that's fine too. The homework quiz right here. Honestly, I think it takes like 5 minutes, 5 to 6 minutes tops. But if you need more than that, if you have a certain time, you get it. All good. If you don't have a sense, I take 15 minutes. Oh, good. And you gotta throw all your notes away. No conferring with each other. All right. Wait. There you go. You want to try it or no? Okay. All right, cool. There it is. Are you? Recordings.